Very nice to meet you guys. My name is Omid. I'm the CTO of Jutomate. It's a company that provides consulting around data. And I'm here to talk about data engineering challenges. This meetup is more like discussion. It's not a full lecture. You can stop me and ask questions as much as you like. You can challenge me. You can turn it into a very live session. So it will be most informative for you guys. So don't hesitate to stop and ask questions as we go along. A little bit about us. Big Data Demystified is a community I opened about 4 years ago. It contains 3 groups. One focused on AWS, one more general, and the most dominant one, and one about BI and analytics. So I usually talk, and all the new content is uploaded here. About me, I have about 20 years of experience in the startup industry, a lot of interesting startups behind me, including some media players, mainly in Israel, called Walla News and investing.com. And this is the consulting company I work for today. As a hobby, I have very nice hobbies. One is martial arts. I'm a black belt in Taekwondo, and a skydiver. And I like to lecture a lot and give my knowledge and share it with the community. So a long time ago, everything was simple. We have a 3-tier architecture where you have a database and an API and a web service and a data warehouse where everything is replicated here and everybody were happy. Then came big data. Big data is essentially a situation where your infrastructure is unable to process the amount of data that comes in, and it constantly breaks or has issues in terms of scalability. Then came the cloud. The cloud made everything much more complicated and swept us all from our feet. And then came the inverse, meaning on top of being a very technology expert, we had to become a very cost-oriented, cost-conscious people, and became more complicated. And as time moved on and kept growing, and the amount of technologies or specialized technologies for specialized use cases, it grew more and more, and it became very complicated to understand and comprehend. So my solution to that was to implement an intersection of cloud methodologies and big data methodologies. And this is what my perception and my philosophy around data engineering use cases. So the agenda today is talk about version control and documentation, cleansing and preparing data, maintaining data pipelines and APIs, and the 4 Vs. Version control. Same as the R&D use case, where you have to develop something and maintain your code in a code repository. The same goes for data pipelines and data projects. For sure, you need to back up your code in a code repository. Not only that, you need to align it with your development environment, dev, staging, master, etc. Usually, in enterprise-grade use case, I recommend using 4 environments: a development environment, a QA environment, staging, and a production. What stands behind it is, 1 second, please. What stands behind this is to align yourself as closely as possible to the R&D processes. Environment suggestion, sometimes you can think on a more lightweight environment. You can skip the QA environment, just have and the staging environment, have only two environments where the local dev is your own laptop where you're developing, and then have a pre-prod and a prod environment. The idea behind it is that on a low-scale environment, you want to test on real data before you deploy to production. So you have a different environment, but the same data is cloned from production to here, so you can work freely and test everything before you proceed. Coding standards for Airflow. Airflow is a tool that helps you write data pipelines. It's open source. You need to keep it simple. As opposed to traditional R&D project, you should avoid object-oriented abstraction as much as possible. The motivation here is to debug complex data pipelines is already complicated without having to deal with complex coding as well. So the more simple and straightforward the code is, the easier it will be to debug data pipeline that will most likely fail in 2 years, 3 years, once running. If you have to do some sort of object-oriented, avoid using code which has more than one layer of depth in terms of the abstraction. Avoid complicated scenarios where you have to use Airflow sensors and Airflow dynamic tags, which are tricky in how to follow and maintain. I also wrote a really nice blog about some guidelines and best practices about a coding job and a debuggable job and right after delete, and some other things you should pay attention while writing a job. This is essentially important for those who are writing jobs on a daily basis for data pipelines. Furthermore, monitoring, the same as any other traditional R&D project, you should have some sort of monitoring on the data layer, meaning, for example, to check if the amount of data that is the new data that was inserted yesterday is the amount of data we are expecting. For example, if you got 0 rows, usually it's a problem on time series data use cases. If you get 100 rows on a regular basis and you got only 10 yesterday, that also may suggest a problem. Let's talk a little bit more about Airflow. As I said, it's an Apache open source project. The pros, the advantages are the flexibility and the customization you can make, and it's ready for scale, and it's very cost oriented. The downside of using Airflow is that it has a steep learning curve. It's a do-it-yourself project, meaning you have to install it and maintain it, and it takes time to write a job. Like any other open source projects, the errors are a bit unclear and make it extremely difficult to understand. Notice you can have MWAA, which is the AWS managed service of Airflow. It's called Manage Workflow Apache Airflow. It has a local runner you can play with via Docker on your local computer. So you can install it quickly, and there you have the there you have Airflow on your computer. You can look for it on Google. And you can follow the instructions here on how to install via CLI. It's very straightforward. Just do git clone and then build the image and you're ready to go. I'll even put that as a link. Another tool, which is a bit different but worth mentioning, it's called Reverie. It's a SaaS tool. The advantage of using it is it has a very nice GUI. It's simple, scalable, and it's trivial when you want to connect to third-party API. You have environment separation, you have kits that are ready-made data pipeline. You can connect to Git and it has excellent support. Cons that the cost is correlated with the amount of data, meaning when you have big data scenarios, it might be worth looking at other open source solutions like Airflow. Any questions so far? Okay. As for the crowd, Airflow is very similar to Luigi. Yes, it was a question from the audience. Quite similar. Is Luigi popular in Europe? In Israel, it's very not popular. I mean, I don't know anyone who uses it. In terms of observability, generally speaking, an architecture of big data is as follows. You have ingestion, which is the layer in the architecture that is in charge only to ingest the data. The transformation layer, which is in charge of cleansing the data, transforming the data, cleaning the data, parsing the data, repartitioning the data, remove mistakes from the data, everything you need to do to make the data ready for analysis, which is the exact modeling layer. The presentation layer is everything you need to do to present the data in a cost-effective manner in the BI tool. If the architecture is decoupled, you have a storage and orchestration layer on the side where it's in charge of the data flow from each layer of the architecture. So essentially, the reason why I mentioned this, that documentation of your data pipeline should rely heavily on your architecture. And once you write an ETL job that starts with the ingestion, then you fix all the data here, then you do all the business logic here, and then you do all the other optimization here. It's very easy to track the job and understand the logic and the flow of the data once it gets into the data all the way back to up to the presentation layer. An example for an architecture on AWS could be one of the following. For example, you use the Kinesis AWS family to ingest data, or Kafka or Flume, doesn't really matter. You put it on S3, which is a storage layer. Then you can use on the transformation layer any database you like, for example, Hive, to parse the data. I'm not sharing the screen. Where I was told the screen was not shared. Let me check. Can you see now? Can you confirm you can see my screen now? Yes? Thank you, Daniel. So where did you lose me? A while back? Yes, super. Okay, so now you can see it. So this is the architecture I was mentioning. And okay, so this is the example I gave about AWS, that you have different technologies for each layer in the architecture, and all the storage is kept here. And here you have some BI tools that are linked to the below. Everything is decoupled. So if your job is properly written using an architecture, everything will be very simple to follow. A simpler architecture would be ingesting the data via Kinesis, and then, for example, using only Athena to do all the layers above it. The same goes for GCP, which is Google Cloud Platform. You can use BigQuery to process all the way of the information all the way to the BI tool. So there's a difference between observability and documentation. The idea behind architecture is to avoid writing too much documentation, which is very hard to maintain. Naturally, you need documentation, but if you keep a strict guidelines about architecture, and the next data engineer that comes and replaces you, reviews your work, will be able to navigate quite easily in your code. So there's a difference between observability and documentation. Observability is to use data QA tools to understand what happens in your data pipeline, what happens in your data, which is a bit different, but essentially observability and architecture are main sources for documentation of the data. So there's a lot of observability tools out there in the market. For example, Monte Carlo, Great Expectation. I recently even encountered something called Soda.io, which is based out of in Europe. Very nice tool. It has an open source version and a paid version as well. Let me add this here. Okay, you have some data pipeline stability, for example, Databand and Honeycomb. You have data lineage to, for example, Apache Atlas and Amundsen. And you should be aware of some data classification issues like PII and financial data and medical data in terms of your documentation and observability. Yeah, there was a question from the audience about the presentation. Yes, everyone who RSVP'd yes to this meetup and will get a link in about a week with the video of this lecture and the slides. The whole idea of this community is to share data for free. That's the philosophy of this meetup. So yes, we are here to help. And we even sent an email about half an hour ago about international WhatsApp group. So you can ask questions for community members about data and get answers. That would be cool. So data lineage is all about understanding the flow of the data, where it comes from, where it goes, and so on and so forth. For example, there's Apache Atlas. There's a really nice document about AWS, from AWS, with introduction to Apache Atlas and how you can use it and leverage it to understand your flow of the data. It's a bit rather advanced for beginners, but just want to give a quick overview to understand that there's a possibility. Thank you, Geraldo Oliveira. Okay. Any questions before I switch to the next session? Notice you're free to open your mics and start a conversation. You don't have to be muted and ask questions via text. Whatever works for you is fine by me. Okay. Cleansing and preparing data. Cleansing is the process of making the data clean and correct. Imagine a scenario when you own two banks, Bank A and Bank B. Both have a table that has the list of cities in Europe. For example, London, Vienna, and so on and so forth. But in Bank A, London is written with lowercase, and in Bank B, it's in uppercase. So the process of cleansing data is to take the data from both banks and transforming it into one single value, which is the same. For example, uppercase London all the way. Okay, is that clear? Very good. Thank you for the feedback. So you have many approaches. For example, the most trivial one would be to take a Python parser, write a simple Python script, and start parsing because you know how to code. If you're a more advanced Python ninja, you have frameworks called Dataframes and Pandas, which help you process data. Again, in the context of Python and coding, very simple, very straightforward. You have ELT methodologies, which is basically SQL transformation and cleansing via tools, for example, Airflow, for example, Reverie. And the fourth approach would be using Spark, either via Pyspark, which is Python for Spark, or Scala for Spark. We'll talk about each of the approaches. The Python parser, the advantage, it's simple and it's generic, very old school. It simply works. And the disadvantage, it's non-uniform. It's very hard to maintain, it's not scalable, and it's bounded in the amount of memory in your server. If we're talking about Python data frames and Pandas, the advantage, it's simple and generic, it's flexible, it's uniform packages across companies, meaning if you go from one company to another and use Pandas, more or less the same concept. As it will be a uniform API and a uniform framework, similarly, of course, you use the same version. And it takes you one step closer to the data science where you can do a lot of advanced math around the data. The disadvantage, it's not scalable again and bounded to the RAM of the server. ELT SQL Transformation. Basically, the full advantage of this would be that it's very close to a petascale scenario. Petabyte scale of data is very challenging to process. So once you use a database which is petascale, you are able to process any amount of data, transform it, cleanse it, and you are essentially able to do 90% of every use case in data in terms of processing. The disadvantage, you have to understand SQL really, really good. And you have some, if you are using a lot of data, you need to have a basic big data understanding. And not everything can be done by SQL. For example, looping over the data again and again. Pyspark, Scala. Or Daniel, you raised the hand.
Yes, but in because of the loops in SQL, you can programming loops in PL/SQL.
Yes, but not always you have PLSQL.
It's not
Not always the use case.
possible. Okay.
Not always. Some databases allow a recursive approach in their syntax, but not all databases. But thank you for your comment. You are more than welcome to participate, everybody. Scala, and Pyspark. So this use case is designed for expert data engineers and complex data engineering use cases. As a rule of thumb, do not use this one unless you're pretty sure you know what you're doing. The reason for that is it's very hard to learn and understand. It's usually involved in complex use cases. It's trivial for simple use case, but the overkill of the maintenance, there's an overkill on the maintenance part, which makes it not worth your time unless it's a specific use case. For example, in a use case where you have schema evolution, sorry, you were saying? Okay. Schema evolution is where you have a data source that on a very short interval changes its schema, its structure on a daily basis. This is usually the case with third-party APIs, where you take for a vendor, for example, a security log, and you get as a data source a JSON, and the structure keeps changing. Every time you pull, you get a different structure. So this is a scenario of schema evolution where every time you approach the data, either a new column is added or a column is removed. So using code for that, for example, Spark, makes everything a lot simpler. Questions before I proceed? Okay. Another popular use case and a challenge for data engineers is maintaining third-party APIs. The whole idea is avoid writing an ETL for third-party API as much as possible, because the challenges around it are quite massive. Let me make sure. Can you still see my screen? Thank you. One, on third-party APIs, versioning constantly changes, meaning every 6 months, the vendor issues a new version of the API, and there's a sunset of the old API. Thus, you may end up with an unsupported version. Thus, your script might fail in production. Thus, you'll have a break in your data pipeline. This is very frustrating to do every 6 months to renew your script. The second challenge would be throttling. The third-party vendor usually decreases the amount of requests per second you can approach. It puts a very, yes, Arthur, the webinar recording will be available later for those who are RSVP, yes. And I will send a link once they're ready to those who are RSVP, yes, in the meetup. Back to the lecture. Okay, so usually what the third-party API vendors, they set a limit for how many concurrent calls you can send to them to get data. The reason for that is usually commercial. The more you pay, the more you are able to extract data. If it's a free source, you should expect there would be harsh limitations. And the challenge around that is how to write a data pipeline that continuously extract data even though there are quota limits, throttling issues, and versioning issues. Example of a use case which is similar of a use case with complex quotas. You can see on the website of the community, Big Data Demystified, again, another blog by me. You can see that there are, one second, please. There's a section in the code. Once I run the code to access the third-party API, when I do two retries for the code. And each time I access, if there's a quota limitation, I do a retry, and then I increase the time every time I call it for an additional 15 minutes, and I do an exponential backoff. What does it mean? That the first time I try, if I fail, the next time would be in 15 minutes. The second time would be in 30 minutes, and so on and so forth. And if I decide to do maximum retries of, say, 10, I even set the maximum timeout. For example, 40, if you can't extract the data in 48 hours, please stop. So this was an example. It's fully documented here, so we have an essence of how complex it is. Questions before I proceed to the next part? Okay. Yeah, 4Vs is a model by IBM where they introduced the following concept. Big data use cases can be differentiated based on these 4 concepts. 1, the volume of your data. You can imagine in a big wave coming as a big amount of data that comes and sweeps you off. If the wave is too big, it will most probably run you over. It's the same in your architecture. If the data volume you are processing is too big, you're most likely to fail in your architecture. Velocity is how many waves are coming per second. Compared to the wave, you have a frequency of, say, 100 drops per second. Each drop by itself is doable, but the question is, are you quick enough to handle the velocity of the new data flowing into the system? Again, assuming water is data in this use case. Variety is types of data. There's lots of types of data. There's structured, there's semi-structured, there's unstructured, for example, video, blogs, images, sound files, so on and so forth. Veracity is when you get a data which has errors and bugs in it. How do you treat it? Okay, summary. Would you like to open your mics and do a quick discussion about what we learned today? I'm looking here because the video is over the left. Please, Daniel.
Yeah, it's for me, everything is very new. I was programming sometimes with Python. I also start some small AI programs like the Hello World possible thing with numbers, written numbers to check which number is it. But this I also visit a session last week about Keras and big data and handle big data and create software to handle big data, but yeah, it's everything very new. I hear a lot of programs I never heard before, and yeah, it's everything very interesting for me, and I'm excited to dive deeper in this.
Okay, so thank you for your feedback.
You're
This is
welcome.
the right place to dive into stuff. Again, not again, but you should go over our website and you can see, wait, can you still see my screen? So there's a lots of different areas within data engineering, data science, and BI. You can just simply start by selecting what interests you and start studying it one by one. Do not attempt to go over everything at once. It will kill you. Pick a subject, try to understand what it does on a general manner, and then go deeper. So back to the lecture. The reason I talked about today's challenges is because at the end of the day, I'm an architect of data. And when I have a new use case, I have this framework in front of me to help me ascertain what would be a good architecture. So my framework is quite simple. It's like a triangle where you have 3 corners: faster, cheaper, and simpler. The idea is to balance between the 3. When you have a good architecture, it's usually faster, simpler, and cheaper. It's usually not 3 out of 3. It's usually 2 out of 3 at least. So it's either fast and cheap, or fast and simple, or simple and cheaper, but it's not fast. Okay. So essentially, we learned about challenges in data engineering. The idea is to understand what will make your data pipeline simpler. And we learned about the 4 V's, and we learned about third-party tools like Rivery, which helps you do an ETL with a very nice GUI without coding. And that simplifies everything. In terms of data engineering, generally speaking, as I mentioned, it's all about faster, cheaper, and simpler. Call to action, you're more than welcome to hit our website and subscribe to a YouTube channel. There's a YouTube channel where all the recordings are uploaded there. And you're more than welcome to stay in touch and check out these links. And that's it. Questions before we conclude? Any comments, anything?
Yeah, I have a question. You were talking about you became a use case, and tried to solve it. So what is a special use case? Maybe you can share with us.
Can you reiterate the question in a different type of word? Yeah, I mean, I didn't understand your question.
Okay, it's about big data. So maybe a company came to you and asked for, I have a big bunch of video material, and I want to see if some people in these videos from my company. Could this be a use case for your company?
Yes. This video usually you can do machine learning techniques to extract the people inside it. You need to do some face recognition and understand that this person is this name, and then you match it with a list of employee numbers and pictures, and then you'll get a sense of what's happening where and when.
Mm-hmm. And do you have another use case for us to share? what your company solve or what a customer
Yes.
came with?
Yes. Well, as a data consulting company, we have many types of solutions for many type of customers. Let's start with the basics one, not basics. Let's go domain by domain. You have cybersecurity companies where you extract a lot of data from many type of sources, mainly third-party APIs, cloud logs, and so on and so forth. You put it in one place, and then you derive insights on it. For example, if you have an attacker that's attacking your digital assets, fraud abuse within your company, this is one use case. Second use case would be financial services. There are many startups and solutions in the last years that are popping up to solve different types of problems in the financial services domain. For example, companies who provide credit cards in the US market for those who don't have credit, a credit score. So imagine the amount of data that's being collected, the amount of AI running on top of it, ascertain if someone is really eligible for credit, even though he doesn't have a credit score. In the healthcare domain, you have many types of use cases. The most common among them is solutions for the elderly, the old folks, your parents, for example, that are around the age of 60. And there are many types of problems with them. For example, they don't want to go to the doctor. Why? Because they don't want to. Sometimes they are alone because their spouse is already dead. So you need some sort of a solution for different type of problems. So the first one would be digital tracking of their day-to-day to find an anomaly in their pattern of in their digital footprints to understand if something happened. Even if you talk to them once a day, something has changed in their pattern. For example, they stopped doing their daily walking activities. They stopped doing yoga. You need to have some sort of alert of that would signal a problem that sometimes they're not even aware. For example, the amount of time they're spending over the phone has decreased in the last 6 months from an average of 10 minutes to an average of 2 minutes. By itself, it's meaningless, but if you get a few types of alerts around that, you will understand something is wrong and you may want to go deeper. Another use case would be on application that helps doctors talk to elderlies and understand if something has changed based on their voice and speech pattern. If the speech pattern has decreased over time, maybe it's an indication for a neurological problem or any other problem. There's many use cases around healthcare, financial services, media, and smart cities. Smart cities, there are many companies around smart cities that have very nice use cases, but in the end of the day, imagine a system of systems, meaning you have as a city, municipality, or any type of small government, you have many type of sources of applications that generate data and you want to aggregate them into one place and generate insights on top of that. For example, imagine a Homeland Security that wants to monitor everything for the police. So you have video feeds from cameras around the country. You have social feeds about people reporting about crime and activities on WhatsApp, on Slack, on Twitter. You have a call center of people calling and reporting stuff. So you need to understand this, understand the different system understand the data, create a data structure that unifies everything into one unified data model. Then you can extract insight on top of that on a simple BI tool with this simple visualization. I can go on and on about use cases. I hope this answered your question.
Yes, very much, and it's very exciting for me. But another very important question came to my mind. Have you ever been bad feeling for a use case that you say, with my ethical standards, I would not solve this problem for you because it's maybe, yeah.
Yes, there are scenarios. Due to confidentiality agreement, I won't be able to talk and share them.
For sure.
But for example, there are a lot of gray areas that companies take your personal identifiable information and sell them. We as a company don't do that, and we avoid helping customers that do that, but it's not always something we know. I mean, we provide service and we organize the data, but if someone has decided to do something illegal, it's out of our hands. But essentially, from the vast experience I have, it's a very rare occasion. Only the big companies do that, and simply because the rest are struggling with the product to get it up and running. They don't have time of making abuse of your personal information.
Thank you very much for your answer.
You're most welcome. Any more questions before we conclude? Okay, so I just want to share with you the fact that we are doing lots of events on this community. It's called Big Data Demystified, but there's a group for every country in Europe. For every company, every country within Europe. So you have Helsinki, London, Berlin, and so on and so forth. But the all network events are managed the same, meaning if I do an event, I call all these groups and the link is the same and we can all talk in English. That's it, basically. That's it. Any more questions before we conclude?
Is there any suggestion for what the agenda is for the next meeting?
Yes, 1 second, please. The next meetup is going to be around BigQuery, which is a database by Google designed for big data. Where are you located, woman?
Pardon me, I didn't read you.
Where are you located? Which country are you
Vienna,
from?
Austria.
Vienna. So if you will check out the Vienna
channel,
group,
okay.
Allow me to share with you screen. So it will be simpler. You'll have the events tab over here.
I see, yeah, okay.
And all the future events will be in front of you. This is today, and this is the next one. You can also send me an email, talk to me. I'm fairly open. And you can join the international group, if you like, of the WhatsApp. I sent an alert about this earlier today. Sorry, oops. That's it, unless you have any more questions.
Oh, thank you for the presentation and the roundup on the tools and methods.
My pleasure. What do you do for a living, Norman?
I'm a former programmer now in process management and service management.
I understand. Okay. I hope you all enjoyed this lecture. Okay, guys. So without further ado, I would like to thank you all for coming and hearing me out and for your patience and collaboration. Have a good one. Goodbye.